Hello guys, good evening to all of you. How are you all? कैसे हो आप सभी लोग? Today in this session we'll be discussing the solution of the Sunday test. So on every Sunday we are conducting a test based on the syllabus we cover in a particular week, and on the last Sunday, means 18th 25th of August Sunday, we conducted a test, and today in this session we'll be discussing those solutions quickly. Okay, so without any further ado, let's start, if everything is all right. Good evening, Harry. Okay, so this Sunday test, the syllabus is this. It starts with coordinate systems, Dirac delta function, differential equation, special function, dimensional analysis, vector analysis, and matrices. And before I start, let me tell you guys, you can join our CSIR-NET December test series. This is an online test series exactly in the form of your CSIR-NET examination interface. There will be total 50 tests that will have 12 full length tests, 2 half syllabus tests, 3 tie unit tests, 5 bi unit tests, and 12 single unit tests, and there will be such 16 Sunday tests. Okay, and this is valid till your December 2024 examination. Other than that, a couple of courses are there. This course is currently ongoing, complete batch courses for CSIR-NET 2024 December and GATE 2025. This course is valid till March 2025, so you can join this course now also. And other than that, we have this course on top 100 most important topics, both in English and in Hindi English mixed. So you can visit our website www.physicshub.in and explore the courses, and you can also download our Physics Hub application from the Play Store, and you can purchase the courses. All the links are given in the description. If you find anything if you have any query, you can let me know on this WhatsApp number 7001439942. You can also call me on this number for any kind of queries or questions. Now, without any further ado, let's start with the first problem. Simple problem. The value of the integral minus infinity to a delta x minus b dx. Can you do this problem? Harry, could you do this? Look, this is a property of the Dirac delta function. What is the property of the Dirac delta function? We have seen that if you have a Dirac delta function, let's say delta of x minus a, or here it is given delta of x minus b. So if you plot this function, as you can see, delta of x minus b, if it is, let's say, b, then you have a peak here. This is the plot of your delta x minus b, and the formula is minus delta infinity to plus infinity delta of x minus b dx. This will be equals to 1. Okay, so this b point must be included in the integration range. Here it is minus infinity to a delta of x minus b dx. Now let's say your a point is situated here. If a point is situated here, then we can say that this b point is included in the range, and at that situation this value will be 1. So this value will be 1 if your a is greater than b. Now this point a is situated, let's say, here. Then between 0 to a, this b point is not included. In that situation the integration will be 0, right, for a less than b. So it is matching with option 2. Tell me guys if you have any doubt or query. Simple problem. I think most of you have done it. If anyone has any doubt, you can let me know in the comment section. I can try to clear that out. Let's go to the next problem if it is done. Let's do it quickly. Evaluate the integral j is equals to this volume integral, this where v is a sphere of radius r centered at the origin. Now this is a very special type of problem. This problem I have taken from Griffith's book actually. In Griffith's this problem was there. So we have a sphere whose center encloses the origin and it has a radius capital R, the volume is V. So you know the volume 4/3 pi r cube, that will be your volume. So as you can see, J is equals to integration over the volume r square plus 2 divergence of r cap by r square. So for this kind of scenario, we know a standard result, the divergence of r by r square. This can be written if this includes the origin, r is equals to 0. If it includes, then the value of this thing is 4 pi times the Dirac delta function delta cube of r. This is the thing we know. So let's put that value 4 pi times delta cube r. So this is 3-dimensional Dirac delta function and d tau. No issue here. Now we just separate the term. So 4 pi is a constant we are taking outside, and we will have two term. One term is this r square delta cube of r integration over the whole range, whole volume, plus 2 times integration over the volume, what we have delta cube of r d tau. Now you know this value will be equals to, you have to put r is equals to 0. So this is 0 square plus 2 times this integration is a complete integration. So this will give you 1. So this is 4 into 2, 8. So 8 pi. Option 4 is the correct option. Is it clear? Let me know. Let's go to the next. Why we put 0? Because you know this formula for Dirac delta function, na? F of r delta cube r d3r or d tau. Okay, this is the volume term. d3r is the volume term. So this is f of 0, na? So here f of r is equals to r square. That is why we have put r is equals to 0. If here instead of delta cube r, if you had, let's say, r minus b, if you had r minus b, what you had, what would you have put here? You would put b. If it had r plus b, let's say, what would be the value then? Instead of this, if it had r plus b, then here you have to put f of minus b. So you have to make this argument 0. So if it only r, then r is equals to 0. If it has r minus b, so r will be equals to b. So in place of r we will put b. If it has r plus b, then you have to put r is equals to minus p. In this way it works. I hope you got it, Harani. Let's go to the next problem, problem number 3. Look at this. Exponential double integration you have 0 to infinity minus, okay, ये क्या symbol आ गया है यहाँ पे, minus x square plus y square dx dy will be. Do it quickly. Could you solve this problem? Double integration between 0 to infinity exponential minus, look at this problem, e to the power minus x square plus y square times dx dy. So if you look at this x square plus y square, we can think that if you go to polar coordinate for the solution of this question, then that will be easier for us. So as per polar equation, 2D the plane polar coordinates, if you can use, there you can let x is equals to r cos theta, y is equals to r sin theta. So your x square plus y square will be r square, and you know the area element in plane polar coordinates is r dr d theta. This is the plane polar coordinate area element. So this will become dx dy. Now our variable is r and theta, right? In polar coordinate our variable is r and theta. So dr and d theta will be there. So the limit of r, you know, limit of r we have 0 to infinity, and limit of theta in plane polar coordinate is 0 to pi by 2. Okay, so the limits will be changed to 0 to infinity and 0 to pi by 2 e to the power minus x square plus y square is r square, dx dy is r dr d theta. Now you can keep this 0 to infinity and 0 to pi by 2 d theta, this you can separate, then e to the power minus r square times r dr. Fine. Now 0 to pi by 2 d theta, this value is pi by 2. So you have pi by 2 0 to infinity e to the power minus r times r dr. Now to solve this, we can let's say this integration is I. So what we can do, let r square, if we let r square is equals to let's say t, then 2r dr will be dt. What you require? You require r dr. So r dr is equals to half times dt, and as a result I will be equals to pi by 2, and the limits are not changing. If you put t equals to 0, r equals to 0, t is 0, r square equals to infinity, t equals to infinity. So the limits are not changing, 0 to infinity e to the power minus t and dt by 2 e to the power minus t dt. So e to the power minus t by minus 1, the simple integration. Now if you put t equals to infinity, that term is 0, then t equals to 0, so 1 and minus plus, so pi by 4. Option 3 is matching. Clear? Yes. This problem I think you could do it. After my solution it may appear to be very easy, but whenever you actually solve in the examination hall, if you don't practice enough, you will find these problems difficult. Let me tell you once again, you need to have practice. And let me give you another suggestion. Every Sunday we are uploading this test, Sunday test, and I am also giving you the video solutions, PDF solutions, etc. But you have to revise these problems. These problems are, I am designing these problems based on the curriculum you are covering, the syllabus you are covering. So this is like you are preparing yourself, your base, your base is getting stronger by giving this test. And whenever you will be giving full length test, that is another thing, but this Sunday test has their own importance. This is meant for your making your base stronger day by day. Let's move on to the next question. Question number 4. The solution of the differential equation, this can be written as. How do we do this? Give it a try. Look, here this y square is creating a problem. So if I take this y square is equals to some variable z, then we can have equations in linear form. Okay, we know how to solve linear equations, but here this non-linear term is creating problem. So that is why we are taking this non-linear term is equals to some variable z, and from this we can get 2y dy is equals to dz, and hence your y dy is equals to dz by 2. So this is your given equation. So just put the value y dy is equals to dz by 2 plus x y square, so xz minus 8x dx. So we have removed the problematic variable, that is y, and at the end we will just replace the value of the problematic variable, then we are good to go. Now we can see that this problem can be solved by using separation of variable technique. We just need to separate the variables of z and x on both sides. Okay, so as you can see, this is dz. If you take x common from here, take it to the other side, then what you have, dz by z minus 8, and on the other side if it goes, you see 2x dx with a negative sign. So we have separated the variable of z and x. So let's take integration on both sides, and as a result an integration constant will be there. So this integration is ln z minus 8, this is x square by 2, so minus x, some integration constant will be, so this is x square plus a, let's say. So z minus 8 will be, if you take antilog on both sides, e to the power a times e to the power minus x square, fine, and hence your z is equals to 8 plus e to the power a is a constant, so you can let that to be c to the power minus x square, and z we have taken y square, so y square is equals to 8 plus c e to the power minus x square. Option 1 is matching. So you see, sometimes question may be framed in such a way that you need to unlock the trick used in the question, the twist you need to unlock, then the remaining solution is very easy. Clear? Okay, and now do this problem. I don't know what does happen to this f of something. Consider a matrix M that obeys m square is equals to I. So this kind of matrix has a name. Do you remember what is this matrix called? I think idempotent. Do you remember idempotent or something? Square of, no, this is not idempotent. Periodic, you can say periodic. No. I is the identity matrix. The matrix exponential I theta m. Theta is a real number, can be expressed as I theta m. You have to find out. look how to solve this problem. M square is equals to identity. So m to the power 2n. So this will be an even number. So m square to the power n. So I to the power n. So this will give you back your identity matrix. On the other hand, m to the power 2n plus 1. So this is an even power. So m to the power 2n times m. So this one we have calculated I. So I times m is equals to m. So we can write exponential I theta m. So just use the formula 1 plus, it is like e to the power x formula. X is I theta m plus I theta m whole square by 2 factorial plus I theta m cube by 3 factorial and so on. Right, let's write another term, I theta m to the power 4 by 4 factorial. Look, sometimes the options may not be given as per our understanding or as per our known formula. Sometimes we need to modify our calculation depending on the given options. Okay. So for this problem, as you can see, if I take this 1 plus I theta m whole square by 2 factorial, let's say we are taking the even powers, I theta m to the power 4 by 4 factorial and so on, plus I theta m plus I theta m cube by 3 factorial plus I theta m to the power 5 by 5 factorial and so on. In first step, why we check first 2 steps, why we check this one, m to the power 2 and m to the power 2n plus 1. Because you see, this is 1 plus I square is minus 1, theta square by 2 factorial. M square is what? M square will be identity. Next, I to the power 4 is plus, theta to the power 4 by 4 factorial. Now m to the power 4. So this is even power. So this 2n is even, right? So whenever we see even power of m, that value will be identity matrix, and whenever we see odd powers of m, that will be equals to m. So that is this thing we are utilizing here, because we have to find out many higher order even orders, no? M to the power 4, I theta m to the power 6, 8, 12 and so on. So that is why we have calculated a generalized formula first. So what will be the next term? Next term will be negative, then theta to the power 6 by 6 factorial will come and so on. गुड इवनिंग नेहा. देखो, और इसमें आई एम वी कैन टेक कॉमन, थीटा माइनस थीटा क्यूब बाई 3 फैक्टोरियल प्लस थीटा टू द पावर 5 by 5 factorial minus dot dot dot. Now here you see all the terms are odd terms, m to the power 1, m to the power 3, m to the power 5. All these terms are odd terms. For odd terms you see m will be coming, so m we have taken common. What is this series? Do you identify this series? This is the cos series. Cos, now it is I is multiplied here, you see m to the power 2n is I, so I is multiplied here, so we can write it as cos theta I plus I you see this is sin theta, but if you multiply with m also, that is also giving you the result. Let us say I times theta m minus theta m cube by 3 factorial plus theta m to the power 5 by 5 factorial and so on. So, we can write it as I sin theta m. So, cos theta I plus I sin theta m. So, option 3 is matching. Clear? Or if you have any confusion here, what you can do, you can just take I common, okay, other things you keep as it is. Theta m minus theta m cube by 3 factorial plus theta m to the power 5 by 5 factorial minus dot dot. This is cos theta. So, this one also you can imagine in this way, that I square, I cube, everything is same. So, you can imagine it in this way. It is like theta I, theta and theta are same, na? Theta I square, theta I to the power 4, because I to the power 4 is I to the power 6 is I. Now, clear? I is the identity matrix. Clear, Harry? Let's move on. Do this one, question number 6. The equation of the curve having slope given by the differential equation x dy dx plus y equals to 0 and passing through the point 1 1. So, passing through the point 1 1 means it is giving you the coordinates of x and y, right. So, for y at x equals to 1 equals to 1, this is the meaning, है ना. So, x dy dx plus y equals to 0. So, here dy dx is the slope. So, you have to find out the equation. So, as you can see, this problem can be solved by separation of variable. You separate the variable of y and x. So, this is dy by y is equals to minus dx by x. Can you write it in this way? Dy by dx is equals to minus y by x. So, dy by y equals to minus dx by x. Variables are separated. So, we can take integration on both sides. Ln y, ln x, some integration constant, let us say ln c. Ln y plus ln x is ln xy, so xy equals to c. Now, it is given that this curve is passing through 1 1, y at x equals to 1 equals to 1. So, just put xy equals to 1. So, 1 into 1 is equals to c. So, c is equals to 1 and that makes xy is equals to 1. Got it? You can guys get the question paper from the Telegram channel. The PDF of this Sunday test has been provided in the Telegram channel. You can join this Telegram channel with this ID Physics Hub 111. Let's move on to the next question. I think this was a simple problem. Suppose P is a 3 by 3 square matrix which is known to have integer eigenvalues. If trace and determinant of the matrix P are 9 and 12 respectively, then the determinant of the matrix is. P is a square matrix, okay, known to have integer eigenvalues. Trace and determinant is given to you. Trace of P. Trace of P, let's say trace is sum of the eigenvalues, lambda 1 plus lambda 2 plus lambda 3, this is equals to 9. Determinant of P, so determinant is the product of eigenvalues lambda 1, lambda 2, lambda 3, this is given to you 12. So what combination of lambda 1, lambda 2, lambda 3 can give this result? What combination of lambda 1, lambda 2, lambda 3 can satisfy both of these equations? You have to choose lambda 1, lambda 2, lambda 3 such a way that sum is 9, product is 12. One took up 4. What 7? No, 9 you require. So 1, 2, 6. So 6 into 2 into 1, 12. 2 plus 1 plus 6, 9. So this combination is satisfying, right? So if you go for eigenvalues of P square, these are the eigenvalues of P. So eigenvalues of P square will be lambda 1 square, so that is 1, lambda 1 square, lambda 2 square, and lambda 3 square, 36. So what is the trace of P square? You will get to know why we are calculating trace. Trace is the sum of the eigenvalues. The eigenvalues are lambda 1 square, lambda 2 square, lambda 3 square. So 1 plus 4 plus 36, so 41. Now determinant of a matrix, determinant of exponential of a matrix, this formula we know that determinant of the exponential of a matrix equals to exponential of trace of that matrix. This is the thing we know. And using that we can calculate determinant of exponential of P square. So it should be exponential of trace of P square. Trace of P square is 41, so e to the power 41. Option 3 is the correct option. Clear? Next problem, you see, very interesting problem. Which of the following graphs best represents the solution of the differential equation provided y at x equals to 0 equals to 1? Very good problem. Let us try to evaluate this. So what is the idea? The idea is to solve the differential equation, and from the solution you need to predict the kind of graph it generates. As you can see, this problem can be done by using separation of variables, right? Separate the variables of y and x. So x times given equation, x times 1 minus y square dx minus y times 1 plus x square dy is equals to 0. Let's check whether I have written it correctly or not, and provided y at x equals to 0 equals to 1. So if you separate the variables, you have y upon 1 minus y square dy equals to x upon 1 plus x square dx. Once you separate the variable, you can take integration on both sides, and look, you can do it directly writing d of 1 minus y square, so minus 2y dy, so you can take minus half common. Here also you can take minus half common, but if it creates problem, you can just take 1 plus y square is equals to t, right? अच्छा वो प्लस था, ठीक. 1 plus y square is equals to t, so 2y dy is equals to dt, y dy half dt. On the other hand, let's say that 1 plus x square equals to z, 2x dx is equals to dz makes x dx dz by 2. Let's put these values here. What you get? Y dy is dt by 2t. Here you get dz by 2z. So this is half ln t, half of get cancelled from both sides. So ln t, ln z plus some constant, let's say ln c. So we have t equals to cz, right? T is equals to 1 plus y square equals to c times z is equals to 1 plus x square. Now put this boundary condition given to you, y at x equals to 0 equals to 1. So wherever you see y, put 1, wherever you see x, put 0. That gives you c is equals to 2, and hence 1 plus y square is equals to 2 times 1 plus x square. Y square plus 1 minus 2 minus, okay, 2 minus 1 is 1, and 2x square is coming, minus 2x square equals to 1. So this is an equation of hyperbola, right? And if you put let's say y square, you can see it is 1 plus 2x square. So at x equals to 0, y square equals to 1, so y is equals to plus minus 1, and as a result you get a hyperbola like this. It is y, this is x. So at x equals to 0, y equals to plus minus 1, this is plus 1, this is minus 1. So hyperbola, how does it look? It should be like this. Okay, so it is given in option 4. So it is passing, this point is 0 plus 1, and this point is 0 minus 1, right? Let's move on to the next question. Problem number 9. Consider the following differential equations where alpha beta are some constant. If the given differential equation is an exact differential equation, then what is the value of alpha beta? So exact differential equation, you know the form m dx plus n dy equals to 0 and del m by del y is equals to del n by del x. This criteria must be satisfied for exact differential equations, right? So here as you can see, this is your m dx, this is n dy. So for the given equation to be exact, del m by del y should be equals to del n by del x, right? It means del y of m is 1 upon x square plus 2 plus alpha by y, del x of n is x y to the power beta plus 1, and as you can see del y, so alpha by y, and hence it is minus alpha upon y square, del x of x y to the power beta so y to the power beta will be there. Alpha is equals to minus y to the power 2 plus beta. From this we need to calculate alpha beta. So let's write it. Let's say alpha is equals to minus 1 to the power 1, okay, minus 1, let's keep it, y to the power 2 plus beta. Here there is no term of y, so we can just write y to the power 0. So y to the power 0 is 1. So if you compare both sides, we can write that alpha is equals to minus 1 and 2 plus beta is equals to 0. That makes beta is equals to minus 2, and hence alpha beta minus 1 minus 2, so plus 2. Option 4. Is it clear, guys? Problem number 10. Which of the following statements is not true regarding delta function? So from these solutions, do you feel that these questions are difficult or not doable? You can easily see that these questions are doable, but you need practice. Not true. So this properties of delta function basically deals with the derivative property of Dirac delta function. You know the original formula, nth derivative of Dirac delta function, one dimensional Dirac delta function, nth derivative is equals to minus 1 to the power n factorial delta x by x to the power n, है ना? This is the original formula. So what is the value of delta x prime, let's say, is equals to minus delta x by x, delta double prime, these two will be utilized, so we are evaluating it beforehand, 2 delta x by x square, na? Now look at this first option, is it correct? X to the power m delta n x equals to 0 if m greater than n. So m greater than n, m is equals to 2, let's say, and n equals to 1, that makes m greater than n, 2 greater than 1. So it is x square delta prime of x, this is equals to delta prime of x, you know, minus delta x by x, so minus delta x by x into x square, so delta x into x, and this is equals to, so delta x has a property that it is infinity at x equals to 0, and for other values it is 0. So x not equals to 0, so this is equal to x equals to 0. For x not equals to 0, this value delta x is 0, so this is 0. So this is correct statement, no issue in this. Next, this equation, if m is equals to n, so let's say m equals to n equals to 1 ले लेते हैं. So x delta prime x, this is equals to minus 1 to the power 1 factorial delta x, so this is minus delta x. So that is why what we have said, x delta prime x equals to minus delta x, so that is also correct. So this equation also holds. Third, let's check the third one. If m less than n, m less than n means m equals to, take, you can take n 1, n is equals to 2, that makes m less than n, है ना? So let's do this three thing here because we don't have space here. By taking m is equals to 1, n equals to 2, m less than n. What is our target? Our target is to verify this. So x to the power m, so x to the power 1 delta double prime x minus 1 to the power m n factorial by n minus m factorial delta n minus m, so 2 minus 1 of x. So this is equals to, you see, minus 2 delta prime x. So delta prime x is equals to, you see, minus delta x by x, so minus minus plus 2 delta x by x, and as you can see delta double prime of x is equals to 2 delta x, this x and this x, x square, and this is true, this is why already you know, so this is found out to be true. So this is a true statement. Now fourth one, let's check, m less than n, then if it is correct, so all the thing will remain same, so x delta double prime x is equals to minus 1 to the power n, n is 2, so 2 factorial by 2 minus 1 factorial delta 2 minus 1 x. So everything will same, only this here plus 2 delta prime x will come. So 2 delta prime x is equals to minus 2 delta x by x. So a minus sign is appearing, but here it is plus, so this is not correct, and this is the correct option. Understood? This was a very good question actually. This is an example, like whenever you are not sure what to do, you can take some example, known example, and you can proceed. Whichever option is found out to be correct, that option is correct. If it violates, then that option is not correct. So here we are not evaluating all these complicated expressions. Because these relations are valid for all values of m and n. So when m is greater than n, so let's say m is equals to 2, n equals to 1. That also m is greater than n criteria is satisfied. M equals to n, both take let's say 1. M less equals to n, so m1 or n2. So this is how you do. Let's move on to question number 11. The solution of the following differential equations, on the right hand side you can see x e to the power x sin x. So this kind of problem actually came in your last exam, na CSR. The only, yes, this is the type of problem came, x e to the power x sin x. Can you do this problem? So this is your second order non-homogeneous differential equation. So it will have two parts of the solution, complementary function and particular integral. So let's evaluate complementary function first. Look, given equation, we can write it in this form. In terms of the differential operator, d square minus 2d plus 1 times y is equals to x e to the power x sin x. Okay. So first of all, we need to find out the complementary function. To find out the complementary function, what we have to do? We have to find out auxiliary. We have to write the auxiliary equation. So m square minus 2m plus 1 equals to 0. This gives you m minus 1 whole square equals to 0 and m is equals to 1 1. Two equal and real roots, and hence we can write complementary function equals to c1 plus c2x e to the power mx, so e to the power x. Now it's the time to calculate particular integral. So as you can see, d square minus 2d plus 1, it is d minus 1 whole square, na? So 1 by d minus 1 whole square, you have to apply it over x e to the power x sin x. Now you know this e to the power x, you can, if you take to the left, e to the power ax, a is 1, so d will be replaced by d plus 1, right? And x sin x will remain e to the power x. So this becomes d plus 1 minus 1 by d square x sin x. As I told you that d is the differential operator, 1 by d is the integration operator, है ना? So let's apply 1 by d. So integration of x sin x dx. So this will give you x sin x, the integration will be, if you take this as u, this as v, so minus x cos x plus sin x, again integration of this thing, so e to the power x, integration of minus x cos x, integration of minus x cos x, then again you can take x equals to u, cos x equals to v. So the first term integration will give you minus x sin x minus cos x, and the second term is pure sin x, so integration of sin x minus cos x. So this is equals to minus e to the power x x sin x plus 2 cos x, and hence the solution is sum of complementary function and particular integral c1 plus c2x e to the power x minus e to the power x x sin x plus 2 cos x. That's matching with option 3. Four more questions. Question number 12. The solution of the differential equation is given as. So as you can see, x square is multiplied, x is multiplied. So what is this name of this equation? Do you identify this equation? What is the name of this particular equation? Harry, what is the name of this equation? This is a very special type of differential equation. It has a special name. Isn't it Cauchy-Euler? Now you know the simple formula of Cauchy-Euler. Look, in Cauchy-Euler we have a2 x square d square y by dx square plus a1 x dy dx plus a naught y equals to some function on the right hand side, let's say q of x. So if you compare, what you get, a2 is equals to 1, a1 is equals to 1 and a0 is equals to 1. So for this, if you take x is equals to e to the power z, that means ln x is equals to z d, so d dx, then your solution becomes a2, so that is 1 times d square y by dz square plus a1 minus a2, so 1 minus 1 dy dz plus a0 into y, so 1 times y, and sine, what we have, sine ln x square. So ln x square is how much? 2 ln x, so sine 2z. Can you write it? And we have now the equation in our standard form. This is 1 minus 1 is 0. This is equals to your sine 2z. So this is a second order non-homogeneous differential equation. So this will have a complementary function as well as particular integral. So let's calculate the complementary function. You need to calculate auxiliary equation. Auxiliary equation for this above differential equation is m square plus 1 equals to 0, m is equals to plus minus I. Okay. So two complex conjugate roots, and you know what is the solution for this? C1 cos x plus C2 sin x, we can write it. Let's go for particular integral. So particular integral equals to 1 upon d square plus 1 sin 2z. So d square equals to minus a square, you need to put. So a is 2, so minus 2 square. Minus 1/3 sin 2z, and as a result y is equals to complementary function plus particular integral c1 cos x is equals to, you see, e to the power z. Acha, this will be not x, it is, z is the variable, no? So z will be there. C1 cos z, z equals to ln x, C2 sin ln x minus 1/3 sin 2z, so ln x square. Clear? So this is matching with option 1. Three more problems we have, let's do them one by one. If anyone has any question, you can ask. Assuming that a polynomial f of x of degree n can be written in terms of the Legendre polynomials as this, then what is the value of minus 1 to 1 f of x pmx dx? F of x is given to you, m is equals to 0 to infinity Cm Pm of x. It means it is C0 P0 of x, C1 P1 of x, C2 P2 of x, let's say Cm Pm of x, and so on. Now we need to calculate f of x pmx dx. So f of x pm of x, if you multiply pm of x on both sides, so what we have C0 P0x pm of x plus C1 P1 of x pm of x, C2 P2 of x pm of x plus dot dot dot. Direct question. Cm pm of x multiplied by pm of x and so on. So if you take integration between minus 1 to plus 1, what you get? You know the orthonormality condition for this Legendre polynomial, minus 1 to 1 pmx pnx dx equals to 0 when m not equals to n equals to 2 by 2m plus 1 or 2n plus 1, whatever you write, because for m equals to 1. So for all the terms, this m and n are not equal. So this term is 0, this term is 0, this term is 0, only this term will survive. So this is equals to 2 by 2m plus 1. So 2cm by 2m plus 1. So option 4. So it's just a problem on orthonormality condition. Direct question, this one, or what are you saying, Harry? Is it understood? Question number 13. If any question you have, you can let me know. Orthonormal. Yes, direct orthonormality. Yeah, we have just used the orthonormality condition. Chalo, question number 14. If j and x is the Bessel function of nth order, then what is the derivative of ddx of j0x? So if you know the formula, you can do it, otherwise it is difficult. So you know this recurrence relation of Bessel function d dx of x to the power minus n jn of x, this is equals to minus x to the power minus n jn plus 1 x, this one you know. So here n is equals to 0, so d dx of x to the power minus 0 j0 x minus x to the power minus 0 jn plus 1, so j1 actually of x, that is d dx of j0 x is equals to, this is 1, so minus j1 of x, option 1. Clear this one? The last problem is a formula based problem. Question number 15. If h and x be the nth order Hermite polynomial, the value of the integration, this is given by. So you can usually use the orthonormality condition, minus infinity plus infinity e to the power minus x square hmx hnx dx is equals to 0 when m not equals to n. Otherwise 2 to the power n factorial root pi when m is equals to n. Yeah, and therefore minus infinity plus infinity e to the power minus x square h9 of x whole square dx. So n is equals to 9 here, so 2 to the power 9 factorial root pi, option 3. So thus we have solved all the 15 problems. I hope you will get some benefit from these problems. The PDF of this question paper has been shared on our Telegram channel. You can join the Telegram channel, the link is given in the description. And if you want to join our CSIR-NET 2024 December test series, you can join now. This Sunday test will be there along with other remaining tests that will make of a total of 50 tests, including full length test, part test and all those tests. So links are given in the description, just check it, and see you guys in the next session. Bye bye, take care. If you are new to this channel, please subscribe the channel and don't forget to press the bell icon. Finally, thanks for watching.